On Unit 2, Lesson 2, Powers of 10 and the Zero Exponent, we're going to learn 5 laws of exponents. We know that a power is repeated multiplication, and there's some patterns that happen throughout this that will come up with 5 laws were developed. So today we're going to do, or in this lesson, we're going to learn about the zero exponent and what happens with that. So what I had the students do was fill out the chart and find the pattern and answer the question below. So if I have, I'm just going to write it, I'm going to type it in. If I have 3 to the power of 5, that's 3 times 3 times 3 times 3 times 3. And in standard form, that would be 3 to the power of 5 is 243. We can't find the pattern until we actually fill out the chart. So I'm going to just copy and paste this down, because 3 to the power of 4 would just be 3 times 3 times 3 times 3. And I'm going to just continue to fill out the chart, so I'm, just deleting. 3 to the power of 3 is 3 factors of 3. 3 to the power of 2 are 2 factors of 3. And then we have 3 to the power of 1, which is just 3. Okay, so let's fill in this stuff in standard form here and see if we can find a pattern. So 3 to the power of 4 is 81. 3 to the power of 3 is 27. You can use your calculator for these. 3 to the power of 2 is 9. And 3 to the power of 3 is just 3. Oh, sorry, excuse me. 3 to the power of 1 is just 3. So let's take a look. How did I get from 243 to 81? Well, I divided by 3. Is that the same pattern for this one? Yeah. I divided by 3. 81 divided by 3 is 27. And it does work for the remaining. So really all I'm doing is dividing by 3. Whoops, that's divide, by the way. So if I wanted to find 3 to the power of 0, which is my next one, I would go 3 divided by 3 to get 1. So using the pattern, we can predict that 3 to the power of 0 is equal to 1. You can go and do this on your calculator, but I just wanted to show you how the pattern worked. Okay, well, let's see if it works for another one. So 5 to the power of 5 is 5 times 5 times 5 times 5. Okay, and I'm just going to copy these and paste these in. 5 to the power of 4. 5 to the power of 3. I'm just going to delete the ones I don't need. 5 to the power of 2. And the last one is just 5. Excuse me. Okay, well, let's see what happens. So this in standard form is just 5. This is 25. I'm going backwards. This would be 125. This should be 625. And if I did this correctly, this should be 3125. Okay, well, let's see what the pattern is. This is divide by 5. To go from 625 to 125, we would divide by 5, because really all we have is 1 less 5, right? We always have 1 less 5. Divide by 5. Divide by 5. That works. So really, if I wanted to find the next one, it would be 5 divided by 5. That is equal to 1. So does the base really matter? Well, it doesn't. So that is one of our laws that we're going to learn. So the zero exponent, a power with an exponent of 0, that's a typo, my apologies, so change that in your book or in your workbook. So a power with an exponent of 0 is always equal to 1. It doesn't matter what that base is. It never matters what the base. Now, this is something you're going to see in high school because, again, mathematicians are lazy. They don't want to have to write everything out anymore or write everything out. So they've come up with a law. So they said it doesn't matter what your base is, but if I raise it to the power of 0, my answer will always equal to 1 under one condition. N can't equal to 0. Okay? So n can be any other integral base It can be any integer, but it can't be 0. And if it isn't 0, then if you raise it to the power of 0, I will always be equal to 1. Okay? So let's put this into practice. So 2 to the power of 0, 1. 9 to the power of 0, 1. Now look here. Negative 2 is my base. So negative 2 to the power of 0, 1. Here, this is like saying negative 1 times 2 to the power of 0. Following the order of operations, we have to do exponents first. So this is like saying negative 1 times 1, which is negative 1. So just be really careful. Be really careful with and ask yourself, is the negative part of the base or is the negative just outside getting multiplied in? 10 to the power of 1 is just 10. And negative 8 to the power of 1 is just negative 8. That's a little important later on. Okay? So I was just checking in just to make sure you're doing that correctly. So here we go. 6 to the power of 0, positive 1. 0.5 to the power of 0, positive 1. Negative 5 to the power of 0, positive 1. Okay? So what we want to do is we want to kind of review powers of 10. So we can write any number in powers of 10. So let's review the standard form of a power. Remember, standard form is just the answer. So 10 to the power of 1 is 10. 10 to the power of 2 is 100. 10 to the power of 3 is 1,000. 10 to the power of 4 is 10,000. Now notice how many zeros I have. I have 1. Look at my exponent. Look how many zeros I have. 2. Look at my exponent. Look how many zeros I got. 3. Look at my exponent. 4. Look at my exponent. So you see the pattern there. Okay? So now let's go vice versa. Let's write these words that are in standard form into powers of 10. So 10 is just 10 to the power of 1. 100 is 10 to the power of 2. 1,000, 10 to the power of 3. 10,000, 10 to the power of 4. Here we have 10 million. Well, how many zeros do we have? 1, 2, 3, 4, 5, 6, 7. So 10 to the power of 7. We're going to use this in order to rewrite numbers. So we can rewrite any number using a power of 10. And this is really important for later on when you talk about scientific notation. Okay? But for now, we're just going to practice the skill. So if you remember, I can write 5,402 as 5 times 1,000, because 5's in the thousands place. 4 is in the hundreds place. 0 is in the tens place, and 2 is in the ones place. So this was expanded form that you learned how to write numbers in way back in, I don't even know, I think grade 4 you learned this. Okay, so now we just learned a different way to write 1,000. We learned that it can be written as 10 to the power of 3. So instead of 5 times 1,000, we can write it as 5 times 10 to the power of 3. Okay, well let's go on to the next bracket. So here we have 100, so this is 4 times 100. Well, you just told me back in the last slide that 100 can be written as 10 to the power of 2. So we have 4 times 10 to the power of 2. 0 we leave out because we don't need to include that because there's nothing in the tens place. It's 0, so we can leave that one out. Now this is the tricky one. How do I write 1 as a power? Well, it can be any base. In this case, we want it as powers of 10. Because remember, any base raised to the power of 0 is equal to 1. So that's how we would write it, 10 to the power of 0. Okay, and the brackets we use in order, just as for clarity, it's not important, but I mean, if you miss them, I can't mark them wrong, but because we would always do the order of operations. But we're just going to put the brackets in just to divvy it up, like just to show your different, like your thousands place, your 10,000s place, your ones place, your tens place. Okay, well, let's practice this. So let's write 978 as in powers of 10. So, I'm going to do this. I'm going to do it typing because it's a little bit faster. So this would be bracket 9 times 100 plus 7 times 10, because 7's in the tens place, plus 8 times 1 because it's in the 1 place. Well, now let's write this as powers of 10. Now I'm going to need to, because it's really hard to do powers. So this would be 9 times 10 to the power of 2, because 100 can be rewritten as 10 to the power of 2, plus 7 times 10 to the power of 1, plus, now we have to write 1 as a power of 10. 8 times 10 to the power of 0, because anything raised to the power of 0 is equal to 1. And we're done. Okay, so let's write the next one. So it'd be bracket 5 times 100,000 plus 4 times 10,000. I'm not gonna put the zeros in. Okay, so I'm not gonna put the zeros in. And 3 is in the tens place, so I'm gonna write it as 3 times 10. Okay, so now I'm gonna write mine as powers of 10. So 5 times 10 to the power of 1, 2, 3, 4, 5. There's 5 zeros. That's a little bit more compact. 4 times 10 to the power of 1, 2, 3, 4. And 3 times 10 to the power of 1, because there's 1 0. Okay? So what we've learned today is that, or in this lesson, is that any base raised to the power of 0 is always equal to 1, but that base can equal to 0. And you can write any number in powers of 10. So during your assigned work, do not use your calculator. Try to do it without using your calculator, and then verify your answers after using your calculator to make sure you know how to use your calculator and know which buttons to press and when. So you are to do 5, 6D, 9E, 9F, 10C, 10F, and 14 on page 61 to 62. I am going to have you, I'm not sure about the assessment focus question. I might have you do them, all of them at the end of after lesson 3.